Hi, in this video I will show how to use BetaMatch to calculate an optimized matching network for a multiband antenna. We will use an antenna called dual band for this optimization. The touchstone data for this antenna is part of the demo data that comes with BetaMatch, and this is also the data that is loaded by default when BetaMatch first is started. You can always also load this data from the help menu. Load demo data and select dual band and click OK. Before we do any calculations, we must get our reference plane right. This is done in BetaMatch by setting the electrical delay. Click on the text electrical delay and enter the correct value in the box. In this case it is 50 picoseconds. Now we must also tell the optimizer which frequency bands we wish to optimize for. In the markers menu, some of the more usual band configurations are predefined. Here we will select pentaband, which will give us the 850, the 900, the 1800, the 1900 and the 2000 MHz bands. Notice that even if we have selected 5 bands, we only have 2 distinct bands in our plots. And this is because the bands we've selected are overlapping and BetaMatch will automatically merge those for us. You can also see that the current frequency bands are shown in the status bar at the bottom of the window. We should also make sure that we are using the correct component series. This is done from the components menu, where you can select whatever series you want. The default selection here is Murata 0402 size components, and those are fine, so I'm not going to change anything now. Now we are ready to optimize. We can start the optimization either from the toolbar or from the optimize menu by selecting the topology we want and just click. So let's start by optimizing for a T network. And there, it's done. You can see the optimized net in the circuit diagram. Seen from the source, it consists of a series 3.9 nH inductance, a shunt capacitor of 1.6 picofarad, a series 2.7 picofarad capacitance, and the antenna. We can compare the performance of this network with the design without any matching network. Click on Original to bring up the data for the unmatched antenna, and we can look at the return loss. The blue curve is the matched one and the black curve is the unmatched antenna. And from the return loss we can see that the matching is much better at the lower end of the low band and the upper end of the high bands. We can also look at the accepted power into the antenna. We can for instance see that we have improved from about 18% to 55% on the high band. These results can also be viewed in tabular form from the markers and data window. Let me rearrange a little bit and expand the windows. We can now see we have from 18 to 55% accepted power at 2170 MHz, and we have improved from 25 to 54% at 824 MHz. Let's save this design, the T network, into memory 1. These are the best results that we could get with the T network. So now we wonder what would happen if we use more components. How much better would it be? Well, let's find out. Let's start a 5-component optimization. It will take maybe 35 seconds on this computer. It's a laptop around 2 GHz, 2 processors. Not the latest model, not extremely fast, and it's also slower because I'm recording this. You saw the T network before. It was almost immediate. 4 components optimization is also typically less than a second. As I see, this one is considerably longer, but during this evaluation the software is actually evaluating 186 million matching networks and picking the best one. Now here we go, it's done. Now we have the best 5-component matching network, and let us compare it to the best T network and also to the bare antenna without any matching network. I will change the view a little bit so we can see both networks at the same time. Turn on memory. So the red memory curve is the T matching network, and the blue curve is the 5-component matching network. We can see here from the accepted power that we have improved from 54 to 77%, and we have also improved from 55 to 66% efficiency at 2170 megahertz. This is quite a big improvement, and it's even more so if we compare with the antenna without any matching network, which is the black data plot here. At 824 we have improved from 25 to 77%. At 2170 megahertz we have improved from 18 to 66%. Quite a significant improvement. This shows the basic optimization you can do, but BetaMatch also has some more advanced features. For instance, you can do active matching. You can change the source to any complex impedance, and also the source impedance can vary with frequency. And some other advanced features are weighting. That means that you can target different efficiency for different frequency bands. You can have pass and reject bands, for instance, to improve isolation between antennas. And it's also possible to match for 2 or 3 antenna sets at the same time. For instance, if you have a flip or slide phone, you can take the data in open and closed position, load them into BetaMatch, and match for them simultaneously. That concludes this presentation. My name is Max Landeus. The address to the webpage and my mail address is on the screen right now. Feel free to contact me if you have any questions or any other feedback. Thank you for your time and your attention.